For this module, organic nomenclature is probably one of the more challenging things to get a grasp on. Functional groups, naming those functional groups, and then all the rules associated with that. So we started off pretty simple. We started off with things like alkanes. Alkanes were just all sp3 hybridized. So here's an example of that, CH2, CH2, CH3. Alkanes, we would name them and the name would end in an ANE, indicating that we have all sp3 hybridized carbons present. So an example of this, I've got 4 carbons, and so I would name that butane. The ANE ending indicating that we are working with alkanes. The next one up, we talked about alkenes. Alkenes have a carbon-carbon double bond at least one point in the molecule. So here's an example of an alkene. They are going to end in ENE, indicating that they have a carbon-carbon double bond there. And now for the first time, this carbon-carbon double bond prevents free rotation. And so because of that, we're going to have one extra thing that we're going to need to add to the name of these alkenes. So the first one up, I've got 4 carbons, 1, 2, 3, 4. So that would still be bute, indicating 4 carbons. The only difference now is that we would add the ENE ending, indicating we have a double bond present. So 1, 2, 3, 4 carbons. So bute, 2-ene. The 2 indicates that I have a carbon-carbon double bond on the second carbon, and the ENE indicates that I have that carbon-carbon double bond. There's one additional thing we can add to that, and that has to do with our relationship across that carbon-carbon double bond. And you'll notice between these two alkenes, both of these carbons are on the opposite side of that carbon-carbon double bond, whereas down here, both of the carbons are on the same side of the carbon-carbon double bond. If we think of the carbon-carbon double bond like railroad tracks. So the one extra thing we can add to that name would be trans-butene, because we have both of those methyl groups on opposite sides of the carbon-carbon double bond. And then down here, so here is trans relationship, here would be a cis relationship. So this would become cis but2-ene. Got a 4 carbon alkene, 1, 2, 3, 4. My double bond starts on the second carbon, and my relationship across that carbon-carbon double bond is cis. The next group that we talked about were alkynes. So here would be an example of an alkyne. An alkyne's got an sp hybridized carbon. And the ending that we're going to use with alkynes is going to be a YNE, indicating that we have that carbon-carbon triple bond present in the molecule. I've got 4 carbons, and I want to have the triple bond have the lowest number possible, so I'm going to count this from the right, 1, 2, 3, and 4. So putting that all together, this would be but1-ine. I've got 4 carbon chain, and on the first carbon of that chain, I have a carbon-carbon triple bond. Now we're going to take a look at some of the other functional groups that we got into, alcohols, aldehydes, ketones. So the first one up is probably the easiest one. I would say our alcohol. So an example of an alcohol, we'll keep everything consistent and we'll have 4 carbons in all of these chains. Right, carbon needs to have 4 bonds total. So we're going to add OL to the ending of any alcohol to indicate we have that alcohol present. An alcohol functional group is a carbon, oxygen, hydrogen. So there's our alcohol. If this was a regular alkane, we would name this butane. All we're going to do is we're going to drop the E and we're going to add OL to indicate I have an alcohol present. And then more specifically, we're going to indicate on what carbon that alcohol is. And again, we want it to have the lowest number possible. So I'm going to count from the right. 1, 2, 3, and 4. So putting that together, butane, 2-all. A 4-carbon chain. On the second carbon, I have my alcohol functional group. Next, we talked about aldehydes. We'll keep that same 4-carbon chain. And again, carbon needs to have 4 bonds total. Aldehydes end in Al. So again, the same thing. This would be butane as a 4-carbon alkane, but we're going to drop the E and we're going to add Al. So this would be butanal. The Al indicating we have an aldehyde present. And that aldehyde is the carbon-oxygen double bond flanked by a carbon-hydrogen single bond. That aldehyde has a carbonyl, the carbon-oxygen double bond. This is our carbonyl. Having the carbon on one side, the hydrogen on the other side, makes this an aldehyde. Next, we talked about ketones. Keep that same 4-carbon chain. And we'll put the ketone there. Again, we're going to add ONE to indicate I've got a ketone present. And our ketone is this carbon-oxygen double bond, flanked by carbon on the left and carbon on the right, making that a ketone. So again, this would be butane if it was a 4-carbon alkane. So we're going to take the butane and we're going to add ONE to the ending. I want the ketone to have the lowest number possible, so I'm going to count from the left. 1, 2, 3, and 4. So a 4-carbon chain. On the second carbon of that chain, I have my ketone. Next, we talked about acids. So carboxylic acids. We'll keep that same 4-carbon chain. Carboxylic acids have that carbonyl as well, the carbon-oxygen double bond, but now they're also going to have carbon-oxygen to hydrogen. So these are not an alcohol, right? They have the carbon-oxygen single bond of an alcohol. They are not an alcohol because we're adjacent to that carbonyl carbon, the carbon-oxygen double bond. These aren't super complicated to name. We would just add oic acid. So this is a 4-carbon chain. So 4 carbons would be butanoic acid. After carboxylic acids, we also talked about esters. Esters also have that carbonyl functional group. So next up would be esters. And again, I'll keep that same 4-carbon chain. So we'll say carbon, 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 Esters are named a little bit differently than everything else that we've looked at up to this point. So esters, we name an ester by breaking it up into both halves of the molecule. First, we're going to take the carboxylic acid half of the molecule, and that's the base name. And so here is a carboxylic acid. So we're going to take the molecule that contains the carboxylic acid, those carbons, so the carbonyl and the rest of that molecule. And the ending that we add here is OATE, but we have to name it in two parts. So the base name comes from that, and then our prefix is going to come from the other part of the molecule. So the prefix is just, I've got a methyl group. And then the base name, I've got 1, 2, 3 carbons. So 3 carbons. Propanoate. Methyl propanoate. We don't need to number it because we're basically numbering it in the name. The name is telling us I've got 1 carbon followed by 3 carbons, and my ester is within those 3 carbons. There's my 1 carbon, and then my ester contains the 3 remaining carbons. Up next, we talked about ethers. Ethers, or carbon, oxygen, carbon. And we name ethers similar to how we name esters. We basically break the molecule up into 2 parts. So the base name is a little bit different here. The base name comes from the longest part. So there would be our base name. There's no special ending that we add. And then our prefix comes from the shorter part. But we include the oxygen. So my base name, 1, 2, 3 carbons. So propane. And then my prefix, I've got 1 carbon and an oxygen, so that would become methoxypropane. Again, like the ester, you don't need to number where that is because in the name, you're basically giving it a roadmap. I've got 1 carbon and oxygen, that's the methoxy, followed by 3 carbons, that's the propane. Other than that, the 2 other functional groups that we talked about, you don't really have to worry too much about the naming. The examples of those would be an amine. So we talked about an amine. An example of an amine would be something like ethylamine. An amine, we are looking for that nitrogen, an alkyl nitrogen or just a nitrogen in general. So that would make this an amine. Ethane, amine. The other functional group we talked about kind of brings together the amine and the carbonyl carbon. So remember that carbonyl carbon is this carbon-oxygen double bond. When we bring an amine together with a carbonyl carbon, that becomes an amide. So this would be an amide, and again, that is only when we bring both of these together. The nitrogen next to the carbonyl carbon. That's what makes this an amide, having both of these connected to each other. If I just had the nitrogen, that's an amine. If I have the carbonyl next to a nitrogen, that's an amide. Don't worry too much about the nomenclature for both of these. We didn't get into the naming of amines or amides at all, but the biggest thing would be just to recognize those functional groups. So hopefully that helps you think about organic chemistry and some of the prefixes and some of the base names and some of the rules that we use to name these organic compounds.